Hey, welcome back. My name is Sushant Satish, and I'm your trainer for this AZ-500 Azure Security Engineer Associate Certification course. In this video, we're going to talk about host security. Let's have a high level look at the things what we are going to learn in this video. We will start with understanding what is endpoint protection and what is PAW, which is privileged access workstations, and what are virtual machine templates and how can you apply these templates, and what are the benefits of using these templates, and how can you remote access management both Windows and Linux machines. How can you use Azure Update Management to update all your virtual machines in Azure? We will talk about how can you protect your disk with disk encryption, and how can you turn on Windows Defender to protect your virtual machine instances. And then we will finish off with Security Center host recommendation and some tips on how to secure your Azure workloads. So without wasting any more time, let's get into it. So what is endpoint protection? Computer systems that interact directly with users are considered endpoint systems. Systems on devices such as laptops, smartphones, tablets, and computers all need to be secure to help prevent them from acting as gateways for security attacks on organizations' network systems. In episode 2, we discussed about shared responsibilities of helping secure services in Azure. IaaS involves more customer responsibility than PaaS and SaaS did. And Azure Security Center provides the tools you need to harden your network, help secure your services, and stay on top of your security posture. The first step is to help protect against malware. So how can you do that? You need to install anti-malware to help identify and remove viruses, spyware, and other malicious software from your virtual machine instance. You can install Microsoft anti-malware or endpoint protection solution from a Microsoft partner as well. Second step is to monitor the status of the anti-malware. So you can do that by integrating your anti-malware solution with Azure Security Center to monitor the status of your anti-malware protection. So what are the reports available in Security Center? You can get reports for endpoint protection not installed on your Azure VMs, or the endpoint protection not installed on non-Azure computers. Some endpoint protection health issues reports like signature out of the date, no real-time protection, not reporting, unknown, etc. So please do have a look in Azure Security Center for these reports. The next topic we need to understand is privileged access workstations. Privileged access workstation or PAWs provide a dedicated system for sensitive tasks that is protected from internet attacks and threat vectors. Separating these sensitive tasks and accounts from the daily use workstations and devices provide very strong protection from phishing attacks, application, and OS vulnerabilities. PAW is hardened and locked down workstations designed to provide high security assurance for sensitive account and task. So what are these attacks? The first one is internet attacks. Isolating the privileged access workstations from the open internet is a key element to ensuring the PAW is not compromised. The second is usability risk. If a PAW is too difficult to use for daily tasks, administrators will be motivated to create workarounds to make their job easier. Third type is environment risk. Minimizing the use of management tools and accounts that have access to the PAW to secure and monitor these specialized workstations. Then we have supply chain tampering. Tracking a few key actions can mitigate critical attack vectors that are readily available to attackers. This includes validating the integrity of all installation media and using a trusted and reputable supplier for hardware and software. Then we have physical attacks. Because PAWs can be physically mobile and used outside of physically secure facilities, they must be protected against attacks that leverage unauthorized physical access to the computer. Let's look at the architecture overview. This diagram is an example which showing a separate channel for administration, which is a highly sensitive task that is created by maintaining separate dedicated administrative accounts and workstation. This architectural approach builds on the protections found in the Windows 10 Credential Guard and device guard features and goes beyond those protection for sensitive account and tasks. This methodology is appropriate for accounts with access to high value assets. So, what are the high value assets? The first one is administrative privileges. PAWs provide increased security for high impact IT administrative roles and tasks. This architecture can be applied to administration of many types of systems, including Active Directory domains and Forest, Microsoft Azure Active Directory tenants, Office 365 tenants, supervisory control and data acquisition or SCADA systems, ATMs, and POS devices. The second asset is high sensitivity information workers. The approach used in a PAW can also provide protection for highly sensitive information worker tasks and personnel such as those involving pre-announcement merger and acquisition activity, pre-release financial reports, organizational social media presence, executive comms, unpatented trade secrets, sensitive research, etc. So what is a jump box? Administrative jump box architecture set up a small number of administrative console servers and restrict personnel to using them from administrative tasks. This is typically based on remote desktop services, a third-party presentation virtualization solution, or a virtual desktop infrastructure, which is a VDI technology. This approach is frequently proposed to mitigate risk to administration and does provide some security assurances. But the jump box approach by itself is vulnerable to certain attacks because it violates the clean source principle. This example figure shows how reversing the control relationship and accessing user apps from an admin workstation give the attacker no path to the target object. The user jump box is still exposed to risk, so appropriate protective controls, detective controls, and response process should still be applied for that internet-facing computer. So what are virtual machine templates? Before diving into configuring VM policies and templates, you need to understand the features and functionalities of Azure Resource Manager. Resource Manager is the deployment and management service for your Azure subscription. It provides a consistent management layer that allows you to create, update, and delete resources in your Azure subscription. You can use its access control, auditing, and tagging features to help secure to organize your resources after deployment. You can use the Resource Manager template to define your VMs. After they are defined, you can easily deploy and redeploy them. I recommend periodically redeploying your VMs to force the deployment of a freshly updated and security enhanced VM OS. So let's dive deep into template design. How you define templates and resource groups is entirely up to you and how you want to manage your solution. For example, you can deploy 3-tier application through a single template to a single resource group, but you don't have to define your entire infrastructure in a single template. Often, it makes sense to divide your deployment requirement into a set of targeted, purpose-specific templates. You can easily reuse these templates for different solutions. To deploy a particular solution, you create a master template that links all required templates. If you envision your tiers having separate lifecycle, you can deploy the 3 tiers to separate resource group. Please note that when you deploy a template, Resource Manager converts the template into a REST API operations. So let's understand how can you connect and sign into virtual machines you created on Azure. Once you're successfully connected, you can work with the VM as if you were locally logged into the host server. So let's learn how can you connect to a Windows virtual machine. The most common way to connect to a Windows-based VM running in Azure is by using Remote Desktop Protocol or RDP. Most versions of Windows natively contain support for Remote Desktop Protocol. If you're connecting to a Windows VM from a Mac, you will need to install an RDP client for Mac. So how can you connect to a Linux-based VM? To connect to a Linux-based VM, you need a Secure Shell Protocol SSH client. Another way to connect to Azure is by using Azure Bastion. Azure Bastion service is a fully platform-managed PaaS service that you provision inside your virtual network. It provides secure and seamless RDP SSH connectivity to your virtual machine directly in your Azure portal over TLS. When you connect using Azure Bastion, your virtual machine does not need a public IP address. Bastion provides secure RDP and SSH connectivity to all the VMs in your virtual network in which it is provisioned. Using Azure Bastion protects your virtual machines from exposing RDP or SSH ports to the outside world. With Azure Bastion, you connect to the virtual machine directly from the Azure portal. Let's understand how can you update virtual machines. Azure Update Management is a service included as part of your Azure subscription. With Update Management, you can access your update status across your environment and manage your Windows Server and Linux Server updates from a single location for both your on-premises and Azure environments. Azure Management is available at no additional cost, and you can easily enable it for your Azure and on-premises VMs. Azure Automation uses runbooks to install these updates. You can't view these runbook, but they don't require any configuration. When an update deployment is created, it creates a schedule that starts a master update runbook and the specified time for the included computers. The master runbook starts a child runbook on each agent to install the required updates. And you can use Update Management solution to manage update and patches for your Windows and Linux virtual machines as well. From your Azure Automation account, you can onboard virtual machines, assess the status of available updates, schedule installation of required updates, and review deployment results to verify that updates are applied successfully to all virtual machines for which update management is enabled. The log analytics agent for Windows and Linux need to be installed on the VMs that are running on your corporate network or other cloud environment in order to enable them with the update management. After you enable update management for your machines, you can view machine information by selecting the computers. From there, you can view information about the machine name, compliance status, environment, operating system type, critical and security updates installed or not, other updates installed or not, things like that. Let's understand disk encryption. Azure Disk Encryption helps protect and safeguard your data to meet your organizational security and compliance commitments. It uses the BitLocker feature of Windows to provide volume encryption for the operating system and data disk of Azure virtual machines, and is integrated with Azure Key Vault to help you control and manage the disk encryption keys and secrets. If you use Azure Security Center, you are being alerted if you have Azure VMs that aren't encrypted. The alert show as high severity, and the recommendation is to encrypt these VMs. So, what are the supported VMs and operating systems? Windows VMs are available in a range of sizes. Azure encryption is not available on basic A series VMs or virtual machines with less than 2 GB memory. Azure Disk Encryption is also available for VMs with premium storage. Azure Disk Encryption is not available on Generation 2 VMs and LSV2 series VMs. So, what are the supported operating systems? It supports Windows Client, which means Windows 8 and later, then Windows Server, which is Windows Server 2008 R2 and later. Now, let's understand the networking requirements. To enable Azure Disk Encryption, the VMs must meet the following network endpoint protection. To get a token to connect to your key vault, the Windows VMs must be able to connect to the Azure Active Directory endpoint. And to write the encryption keys to the key vault, the Windows VMs must be able to connect to the key vault endpoint. If your security policy limits access from Azure VMs to the internet, you can resolve the preceding URI and configure a specific rule to allow outbound connectivity to the IPs. So, what are the group policy requirements? Azure Disk Encryption uses the BitLocker external key protector for Windows VMs. For domain joined VMs, don't push any group policies that enforce TPM protectors. Azure Disk Encryption will fail if domain level group policy blocks the AES-CBC algorithm, which is used by BitLocker. And the last one is encryption key storage requirements. Azure Disk Encryption requires an Azure Key Vault to control and manage disk encryption keys and secrets. Your Key Vault and VMs must reside in the same Azure region and subscription. Let's understand Windows Defender. Windows 10, Windows Server 2019, and Windows Server 2016 include key security features. They are Windows Defender Credential Guard, Windows Defender Device Guard, and Windows Defender Application Control. Windows Defender Credential Guard uses virtualization based security enhancement to isolate secrets so that only privileged system software can access them. Unauthorized access to these secrets might lead to credential theft attacks such as pass the hash or pass the ticket attacks. Windows Defender Credential Guard helps prevent these attacks by helping protect integrated Windows authentication, which is NTLM password hashes, Kerberos authentication ticket granting tickets, and credentials that applications store on domain credentials. And Windows Defender Application Control helps mitigate these types of threats by restricting the application that users can run and the code that runs in the system core or kernel. Policies in Windows Defender Application Control also block unassigned scripts and MSIs, and Windows PowerShell runs in constrained language mode. Let's look at some of the Security Center recommendations. Azure Security Center helps you prevent, detect, and respond to threats with increased visibility and control over the security of your Azure resources. Security Center helps you safeguard VM data in Azure by providing visibility into the security settings of your VMs. So, what are the capabilities available? You can get OS security settings with the recommended configuration rules. You get security system updates and critical updates that are missing, endpoint protection recommendations, disk encryption validation, vulnerability assessment and remediation, and threat detection. You need to enable data collection so that Azure Security Center can gather the information it needs to provide recommendation and alerts based on security policy you configure. This is an example of the data collection has been turned on. Security Center threat detection works by automatically collecting security information from your Azure resources, the network, and connected partner solutions. It analyzes this information, often correlating information from multiple sources to identify threats. Security Center prioritizes alerting along with recommendations on how to remediate these threats. And Security Center employs advanced security analytics that go far beyond signature-based approaches. And Security Center takes advantage of breakthroughs in big data and machine learning technologies to evaluate events across the entire cloud fabric, detecting threats that would be impossible to identify via manual approaches and predicting the evolution of attacks. Some of these analytics include integrated threat intelligence. This seeks known malicious hackers by taking advantage of global threat intelligence from Microsoft Product and Services, the Microsoft Digital Crimes Unit, and the Microsoft Security Response Center and external feeds. The next one is behavior analytics. This applies known patterns to discover malicious behavior. And the third one is anomaly detection. This uses statistical profiling to build a historical baseline. It sends alerts on deviations from established baselines that confirm to potential attack vectors. Using these analytics, Security Center can help disrupt the kill chain by adding detection in different phases of the kill chain, as shown in this example. Microsoft Cybersecurity Group, in conjunction with Center of Internet Security, which is known as CIS, has developed best practices to help establish security baseline for Azure protection. The CIS Microsoft Azure Foundation Security Benchmark Guide provides perspective guidance for establishing a secure baseline configuration for Azure. A variety of security standards can help cloud service customers to achieve workload security when using these cloud services. These recommendations should not be considered an exhaustive list of all possible security configuration and architectures, but just as a starting point. Alright, so that concludes the episode on host security. In the next video, we're going to enter a brand new episode, which is episode 11, and the topic is container security. So I will see you on the next one. Till then, take care.